Okay, now number 6 in this set of problems is actually one of the harder problems on this entire review. It is a solving problem, and it has to do with rational expressions. Usually these are pretty difficult. Okay, they can be really confusing for students, no matter how easy they look. And sometimes you'll end up with multiple answers, and sometimes not all those answers work, and you have to figure that out. Okay, so let's go ahead and get started. How do we do these? Well, kind of borrowing from that other problem we did, where we had stuff with fractions and like different denominators. We have to figure out an LCD or an LCM, however your teacher might talk about it. It's basically the same thing, no matter what. Let's just think of it more like an LCD, but we're not actually going to keep the fractions. This was kind of weird. Whenever we solve, we get rid of the denominators, because we don't want to deal with fractions. But only in this case, if we're solving. That's the entire difference here. If you're not solving, then we're going to keep the denominator the whole time, okay? So, I'm looking at all this. I got an X, a 5, and a 10. Now, because whenever I've asked students this in the past, they usually say, oh, it's 5X. It's not true. You want to go with a bigger number. 5 goes into 10. So it's actually going to be not 5, but it's going to be 10X. Okay? Now, what I'm going to do with this 10X is I'm going to multiply this entire problem by 10X. And then I'm going to, figure out what cancels with the denominators, and then I'm not going to have any. So, how do I do this? Depending on how your teacher did it, they might do it something like 10x times, and they have x over 10 plus 4 over, equals 4 over 5 plus 2 over x. So they might do it like this. Just have the 10x there, and then they start doing stuff inside. They might have it over 1. They might do it where they have a 10x over 1 next to everything. So you might have 10x over 1 times x over 10, like this, equals 10x over 1 times 4 over 5, like this, plus 10x over 1 times 2 over x. Any one of these is okay, as long as you know that we're going to be doing the same thing no matter which one we're doing, okay? That this right here means what's down here. That all of these are going to get multiplied by that. And I think it's just easier to kind of write it like this from the beginning. So now I look at this. Remember, I can cross cancel here, so I'm looking, and I say, ooh, in the crosses, there's a 10 and a 10. What's left over? This x and that x, and a 1 down there. Well, it's a 1, who cares? Okay, so I get x times x, which is x squared. And I'm finished. No fraction. It's gone. It's gone. You did right. You still have a fraction, you still have a denominator. Something's wrong. Something didn't do it right. Now here I have a 5 and a 10. 5 goes into 10 how many times? Twice. So now I'm left over with a 2x times 4, which is 8x. No denominator. So that's just a 1. Nobody cares. Okay. Now, here I have in the crosses x and x. Now what I have left over is 10 times 2, which is 20. Alright, so now I have x squared is equal to 8x plus 20. We're good. The next thing I want to do is I want to bring everything over on the same side. Now you might be like, oh, okay, let's just minus the x squared. Don't do that. We don't like negative x squared. Don't want negative x squared. So we bring everything to x squared, okay? So don't ever do that. So I'm going to actually move 2 things instead of 1 to make it easier. So now I get x squared minus 8x minus 20. I didn't put anything together. Just wrote them with minus signs, equals 0. Now you might be like, okay, what are we going to do now? How are we going to solve this? Well, we're going to try to factor this. Let's see what we get. Okay, so let's go ahead and factor this. So I know I got an x and an x. Alright, equals 0. If you remember my factoring rules from the beginning, if this is a minus, I know 1's a plus, 1's a minus. What multiplies to get 20? Well, we got 4 and 5. That's never going to give me 8 in the middle when I'm adding or subtracting. I have 10 and 2. That can give me 8. Now it's a negative 8. So because it's got a minus there, the bigger number is going to be a minus. So that should be minus 10, alright, and a plus 2. Now, almost done. I have to take these and set these equal to 0 individually. So x plus 2 equals 0. But that's solve. This is my solving part. X minus 10 equals 0. I minus the 2. I minus the 2. X is equal to negative 2 is the one there. Add the 10. Add the 10. X equals 10. Okay, that's the other one. So, these are my answers. Now, in these cases, you don't just want to trust that these are the answers. You actually want to go back to the very beginning, that problem up there, and you want to try plugging these in to see if they work in a calculator or just by hand. So you always want to go back and see if they work in these equations, in these problems, okay? And in this case, they both do, because sometimes only one works. And in that case, you have to say no to the other answer, and you have to like cross it out. You don't want to circle it. But in this case, they both work. Just be careful, because sometimes it's not going to happen. All right, let's move on to some easier problems. Okay, next one says simplify. This is off of the radicals from chapter 8. So in this case, what I need to do is just break this down. Best thing I like to do is I like to break this up to have the number separate from the variable, so I have square root of 50 times square root of y to the 6th. Remember, I talked about knowing those square roots. Now, 50 is not a perfect square, okay? But there is a number that goes into 50 that is, which is 25. So I want to break up 50 to be square root of 25 times square root of 2. I can do this. That's going to give me 50. The nice thing about square roots here is that you can break them up as much as you want with their multiples, things that go inside, and then bring them back together in the end. Now, this square root of y to the 6th power, I want you to think about it like 2. So I said, how many times does 2 go into 6? Well, 3 times. It goes in perfectly. No leftovers. No remaining. So to take the square root of y to the 6 is just y to the 3. You use division to do it. Okay? Not really using division, but in your head you want to try to think of it like division. Now the square root of 25 is 5. So this comes out as 5. I have 2 things that came out perfectly. There is no square root of 2. It's just, what you see there, square root of 2. So I'm going to put together the things that are out of the radicals, the 5 and the y to the 3rd, and take the thing that is in the radical still, the square root of 2. This is my answer. Okay. Now, number 8 is asking us to solve. And in order to solve it, I need to get rid of this radical to get to x. Okay, so whenever you're solving these, this is again from chapter 8, is to get rid of the radical, like to get rid of the radical of 3, you want to square it. The square knocks out the radical, and I just get 3. So in this case, I want to do that. So I want to square this side, but I also have to do it to this side. I can't just do it to one side and not the other. So if I go ahead and square this, that knocks out the radical. So I left with 2x plus 4, no radical. Now my x is free to be solved for. On the other side, 6 squared is 36. You have to do that. If you don't, it's going to be wrong. Now I just go about solving this like a normal, solve for x problem. So minus my 4, 2x is equal to 32. Divide by 2, and I get x is equal to 16. Okay? Every time you do these, you always want to check your answer. You always want to check and make sure that this works. Don't ever think, oh, I'm done, I can move on. Please go back and check. Go back to your original, not this part. So you have square root 2 times 16 plus 4 equals 6. I want to see, does this work, okay? 2 times 16 is 32 plus 4 equals 6. Does it? We don't know. And then this ends up being the square root of 36. We do know that. 6. It does work, okay? So x equals 16 is the right answer. But please always go back and check. Plenty of times when it doesn't work, and students get it wrong because they were going too fast and not paying attention. Alright, number 9 is asking us to solve. Okay, so looking at this, I'm going to solve for x. I got some stuff to do before I can do that. So, to do that, I need to distribute that 5 in. And over here, this is like a minus 1, or just a minus sign, but I need to put that into both of these. I can't just start moving stuff around. So, on the left-hand side, 5 times 5x is 25x. 5 times 9 is 45, okay? On the right-hand side, my 3 stays the same, it doesn't change. Then I get minus x, minus 10. Both of these get the minus sign, okay, not just one of them. Now from here, I have some like terms on this side I need to put together before I start moving stuff. Don't do that just yet. 3 minus 10 is negative 7. So I get negative 7 minus x. Left-hand side stay the same. Alright, now I start moving stuff. Move stuff from the left to the right. It's up to you. You want to move x's first, you want to move numbers first, you want to move from what side, whatever. We don't care. I'm going to move my x's first. Add my x, add my x. So I get 26x plus 45 equals minus 7. Minus my 45, now those are my numbers. Minus 45. Draw my line. I get that this is negative 52. 26x. Now I divide by 26, and I end up with negative 2 is x. Okay, and I'm done. So I gotta do that problem. Don't have to go back and check my answer or anything. I mean, I can. Might be a good idea to, but don't really have to like the other problems where you really. Okay. Look at the next one. All right, for solve by factoring. Okay, couple ways to do this. This is a special one. So this has a number in front of x squared. Because it has a number in front of x squared, I'm going to show you the illegal maneuver, or the shortcut method, or whatever the teacher's going to call it, I don't know. But it's the one I like the best. It works for all of these. The only time it doesn't work is if they have a greatest common factor. You got to take out the greatest common factor first, okay? Every time we can do it. So, this is the illegal maneuver. Your teacher showed you the AC method. Awesome. I do not know how that works. I probably just spelled maneuver wrong. I don't care. But I have no idea how that works. I don't like it. I don't use it. I mean, it's great the teacher does it, and they know how to do it, and they taught you, but I don't like it, so I don't use it. So I use the legal maneuver. All right, so how this works, and I mean, either way, we're going to get the same answer. So if you want to use your method that you know, see if it works the same as mine, check your answer at the end, okay? So, illegal maneuver. First thing you do, you take the first one and the last one, multiply them together. This knocks out the front one, okay? I'm left with x squared. No 2, it's gone. Minus 15x. Nothing changed there. Sign didn't change, number didn't change, x didn't change. 2 times 8 is 16. Minus 16. This changed. That changed. Those are the only things that should change, okay? Sign didn't change. Now I factor like normal. So now we're just going to go ahead and factor like normal. Factor x and x. They're all going to be like that. Now, remember we talked about our rules. I see that this is a minus, so one's a plus, one's a minus. I see that this is a minus, so I know the bigger number is going to be a minus. So what multiplies to get 16? Well, there's 8 and 2, but that's never going to give me 15. And there's 4 and 4, and that's never going to give me 15. But there's also 16 and 1. That will give me 15. If I make the 16 minus and the 1 a plus. So in this case, I will get negative 15x. Now that I've done this, or I can solve. Now, in the beginning here, I multiplied this. To compensate, I now need to divide. So if you think to yourself, multiply here, divide here, okay? So I multiply by 2, I'm going to divide by 2 on both of these. Now, on the left-hand one, 1 can't be divided by 2, it's a fraction. So in that case, the 2 goes in front of the x. So I'm left with 2x plus 1. The 1 doesn't change, the sign doesn't change, it just becomes 2x. Over here, 16 can be divided by 2, it's 8. Nothing left over, so it's just 8. Okay? Just like that. Sign didn't change, nothing like that changed. Equals 0. If you don't believe me that this works, take this and try to go ahead and FOIL this out. FOIL to check. Okay? If you end up with what you have at the beginning, that thing, you did it right. Okay? Now, because this is a solve by factoring, most of the time we'd be done otherwise. Since it's a solve by factoring, I need to solve for this. So I take the 2x plus 1. We've already done a solving by factoring. And the x minus 8 equals 0. And now I just solve for x. Minus 1, minus 1. I get 2x is equal to negative 1. Divide by the 2. And I'm left with x is equal to negative 1/2. It's okay to get a fraction here. It's okay. I know we said earlier that we don't want to have fractions. But this is okay. We're just solving. Alright. Now on the right-hand side, I add my 8, and I add my 8, and I get x is equal to 8. Both these answers work. Both of them are okay. I want them both. This is how you do this. Just using the illegal maneuver. It's really awesome. Hopefully you kind of learn how it works. But if you don't know, use whatever method you learn in class. Okay? I'm not trying to trump what the teacher says. It's just the way that I like best to show students. So that's what I'm going to do in my review. All right.